In this program, we would like to print the multiplication table. Observe that the multiplication table is like 1, 1, 1, 2, 2, 2, 3, 3, 3, and in every step we are printing the bunch of other items. So it seems like a couple of loops, 1 over the 3 and 1 over the 4, is enough to get all of the possible values. Then we just multiply them. To do that, I'm here making an iteration over the 1, 2, 3, 4, and in every one of them I'm making another iteration on, let's say, 1, 2, 3, 4, 5, 6, and in every time we are multiplying these two values together to get the target multiplication table result. That's all. Try to like memorize that such a kind of n times m operation would require from you to do some nested looping. In the last program, the special sum program, we would like to compute this term, but we would like to not use the power operator. And also observe here that we are also reading the number of test cases. So it seems that we have like multiple loops to get this problem done. Specifically 3 loops. The first loop is like clear enough. This is a while of the number of test cases. So we are looping over the number of test cases. And after that, we know that every test case will have a bunch of numbers here. For example, here 3 numbers, here 4 numbers. So we need another for loop to start to read for us the numbers one by one. The last thing, we need something to compute the result for us, and it seems that the result for us depend on the current count. So if you are the first number, you just use it once. Second number, you need to use it twice, 3 times, 4 times, and so on. So we need one extra loop that's actually based on the current step. In every step, we are computing the power here, which is just like if you have a d and to the power 4, then you need a loop of 4 times to multiply the number by itself. This is how we can structure the program in itself. I know that this might be a bit annoying in the beginning. If it is the case, then just come back later and try again. That's all.